So for the question 8, we are given this diagram which shows a triangle ABC in which angle B is a right angle. Then there is also the length of AB and BC given to us as 8 centimeter and 4 centimeter respectively. Then there is also a point D such that AD is equal to 5 centimeter. Now there is also a sector DAC. So this is forming a sector which is actually a part of a circle with a center at point D. Now in the first part of question 8, we are asked to find the perimeter of this shaded region. So it basically requires us to find out the length of this AC, and then it also requires us to find out the length of this arc AC. If we are able to find this, then our job is done. We simply need to add them together to find the perimeter of this shaded region. So let's go ahead and first of all figure out how we can find out the length of AC. So as we can see that this is a right angle triangle, we can simply go ahead and implement Pythagoras theorem to find this AC length. So we can say that therefore, or not therefore, my usual habit is to go ahead and say therefore, but yeah, we'll say that AC is equal to square root of 8 square. This is 8 square plus 4 square. And now if you solve this in Calci, you will be getting 4 root 5. Now comes the arc length. So for this arc length, it is important for us to find this angle over here. So let's call this angle as theta, because I know that I can find this theta with the help of tan, because we know that tan theta is equals to opposite over adjacent, and I have both of them, and that's the reason I have chosen tan theta. So tan theta is equals to 4/3, which simply means that theta will be equals to tan inverse of 4/3. Now make sure that your Calci is in the radians mode, because in this particular chapter of sectors, we deal only in terms of radians, right? So yeah, that's theta, that is what we are having. And this angle will simply be pi minus that theta, because this is complete 180, which in radians is actually pi radians. So from this pi, we are subtracting this theta to get this angle, right? So yeah, that's your pi minus tan inverse 4/3 will give you this angle. And now to get the length of this arc of AC, to get the length of arc of AC is equals to radius times this theta, right? So radius of this DAC is 5. And if we multiply it with this angle pi minus theta, that is 5 multiplied by pi minus tan inverse of 4/3, we are going to get some answer. So let's go ahead and check that. So 5 into pi minus, once again I'm saying, just make sure that the Calci is in radians mode. So tan inverse of 4/3. So that gives us 11.07148 something. So now the perimeter, therefore perimeter of shaded region is simply the addition of these two values, right? So if I take this value and I add 4 root 5 to it, I am getting the value of 20.0 centimeter, correct to 3 significant figures. So that's your answer to the first part of question 8. And now in the question part B, I believe that they must ask us what is the area of the shaded region, the classic questions that we get from this chapter. Yes, find the area of the shaded region. So let's talk about that. So I'll just first of all get rid of this and create a space for us. So now in order to get this shaded region, what we can do is, we can first of all find what's the area of this whole sector DAC. And then from that, we can subtract this area of the triangle ADC. So from the sector, if you get rid of this triangle, you will be getting only the area of the shaded region. So let's go ahead and do that. So for that, I'll just keep this as it is and move to the next page. All right, and let's say that this is, I'll just complete this diagram. Let's say this is the shaded region. And if I have to complete this, it's going to look something like this. So it was A, D, and C. And we also know that theta is equals to tan inverse of 4 by 3. So now if we go ahead and say that area of sector ADC is equals to, we know the formula is half r squared theta, right? Half, the value of r is given to us as 5, and the theta that is over here is pi minus theta. So half r squared into theta. What is theta? Pi minus tan inverse of 4 by 3. So if you solve this inside, you can see 0.5 into 5 squared, and then multiply that value with pi minus tan inverse of 4 by 3, we get a value of 27.6787 centimeter square. And then now if you find out the area of this triangle, the formula that we can use over here is half AB sine of this angle, right? So this and this side are at nothing but 5. So therefore we can say that area of triangle ADC is equals to half into the product of the adjacent side of this angle basically. So that's 5 squared times sine of the angle, that is pi minus tan inverse of 4 by 3. So now if we solve this in Calci, so 0.5 into 5 squared into sine of pi minus tan inverse of 4 by 3, it's giving me the exact value of 10 centimeters square. And as I told you, to get this shaded region, we need to do the whole sector minus the triangle. So therefore I can say that area of shaded region will be equal to, if I take away 10 from this value, if I take away 10 from this particular value, I'll be left with 17.7 centimeters square, correct to 3 significant figures. So that's your answer to question 8, part B.